AP Calc BC. In this video, or this section, we're going to do section 9.2, which is the derivatives and the integrals of the hyperbolic trig functions. So just like we can take the derivatives and integrals of our other trig functions, we can do the same thing with the hyperbolic trig functions. And since they are rational combinations of the function e to the u, that makes it pretty clear cut about how we should take their derivatives. So we can go through this derivation of it. So you know that sinh is 1/2 e to the u minus e to the negative u, and cosh is the same thing except the plus sign in the middle. So then if you consider that and just take the derivative of what you have there, and remember, you've got to apply your chain rule, right? You've got to take the derivative of the u, or whatever is attached to as your exponent on e. If you run through that, we get some nice rules for the derivatives of those hyperbolic trig functions. So the derivative of sinh actually works out to be cosh with the derivative of u attached to it. So that goes back to our chain rule. And then the derivative of cosh is sinh with the derivative of u attached to that. Okay, now one thing to notice, that this isn't too far off from our normal trig functions. And notice though that when we take our derivative of cosh, it's not sinh, okay? It's not negative sinh like it is in the real world. It's actually a positive sinh. So that's just the one difference there. So we can keep going through this, and we can take the derivative of tanh in the same way. And then the derivative of tanh is sesh squared with the derivative of u attached to that. So again, the chain rule comes into play there. And so then we can go through all of the other hyperbolic trig functions, and we can get these rules as well. So the derivative of coth is negative cosesh squared with du attached. The derivative of sesh is negative sesh u tanh u. And again, notice that that is negative there. Okay, so you've got some flipping in your signs here. And then the derivative of cosesh is negative cosesh coth. And all of these have the derivative of u attached to it. And just like we can take our derivatives, well, then we can also take our integrals. And so here we have a table of our integral rules. So the integral of sinh is cosh. The integral of cosh is sinh. The integral of sesh squared is tanh, right? And these, it keeps going on with whatever rules we have, the reverse of the derivative rules. So I've got a few examples that I've copied here in your notebook for you, so I'll let you look over those on your own. They're pretty straightforward. But what I'm going to do for you now, I'll do some of the examples from the problems in the back of this, and then you'll have your assignment to work on your own. So I'm going to do number 2 and then number 24. So for number 2... for that problem, let's see, we just have to find the derivative of y is cosh squared 5x, okay? So we have y is cosh squared 5x. So, well, dy dx, our derivative of, first thing we need to think about is the chain rule. So this is a cosh squared, so the outside function of that, you can think about that is our square. So it's going to be 2 times cosh 5x first, and then so I've peeled away one layer of the function, and then the next layer to go into is the actual derivative of cosh, which is sinh. Okay, so the next layer is the derivative of cosh, which is sinh. So we're going to have sinh 5x. And then the next layer inside of that, following along with our chain rule, is the derivative of the argument of that, which is the derivative of 5x, which is just 5. Right? So then if we simplify all of this, we can say that dy dx is going to be 10 cosh 5x times sinh 5x. And And that's your answer there, and you're all done. Going on to number 24. For 24, we've got to evaluate an integral, and the integral that they give us is the integral from the natural log of 2 to the natural log of 4 of cos x dx, okay? And so for this one, I can rewrite cos as, I'm going to go ahead and rewrite this as cos x over sinh x, right? And we'll evaluate that with respect to x. And I think I'll do this with u substitution. I can let u be sinh x here. So then that would mean du is going to be cos x dx. So then we could say that dx is going to be du over cos x. So then I can go ahead and work with my integral. So then that would mean that the integral of cos x over sinh x dx is going to turn into the integral of cos x over u times, I'm going to replace that dx with this du, or that dx with this dx right here. So that'll be du over cos x. And so then my cos x's will cancel. And so then this is going to turn into just the integral of du over u, which you know is going to be the natural log of the absolute value of u. So then we can take this a step further, and we can say that the integral of the natural log of 2 to the natural log of 4 of cos x over sinh x dx is going to be the natural log of the absolute value of sinh x evaluated from the natural log of 2 to the natural log of 4. So that will turn into the natural log, let's see, that's going to turn into the natural log of the absolute value of sinh times the natural log of 4 minus the natural log of the absolute value of sinh times the natural log of 2. Right? And so then if we evaluate those sinh functions, so then we could take this one step further and say this is going to be the natural log of e to the natural log of 4 minus e to the negative natural log of 4 over 2 minus the natural log of e to the natural log of 2 minus e to the negative natural log of 2 all over 2. Okay, so then if we simplify that, we're going to have the natural log of 4 minus e natural log of 1/4 all over 2 minus the natural log of 2 minus e to the natural log minus e to the natural log of 1/2 all over 2. So then that will turn into the natural log of 4 minus 1/4 over 2 minus the natural log of 2 minus 1/2 over 2. Okay, so then, let's see, trying to break this down to be as simple as possible. So we'll get the natural log of 15 over 4 times 1/2 minus the natural log of 3/2 times 1/2, right? So then that'll turn into the natural log of 15 over 8 minus the natural log of 3 over 4. So then you have subtraction there. So then you can combine these natural logs using division. So then this becomes the natural log of 15 over 8 times 4/3. And so then I can cancel between those, right? So this becomes a 5, that becomes a 1, this becomes a 2, that becomes a 1. And so your final answer is going to be the natural log of 5 over 2. And that's it. So hopefully from those examples, you have an idea of how to do some of the problems in your assignment.